Good afternoon and welcome once again to the group exhibit Hydrogen and Fuel Cells at the Hanover Fair 2012. We have another interesting talk for you today called Engineered Carbon Solutions for Fuel Cells. With me today, I've got two gentlemen from Ballard Material Products. We have Guy Abrell, Sales and Marketing, and Bill Folds, the President. Please join me in welcoming them on stage. So, welcome.
Thanks for having us, Christine. It's great to be here.
Good. Are you enjoying it so far?
Oh, it's been a great show. Excellent.
Fantastic. Now, Ballard is a pretty well-known name within the hydrogen and fuel cell community. Could you explain the difference between Ballard Material Products and Ballard Power Systems?
Yes. Ballard Power Systems is well known as a manufacturer of fuel cell stacks. They've been in the business for many years and hold a fairly significant market share in that technology. Ballard Material Products is a company that works in engineered carbon materials. So our business is the materials business. We develop primarily carbon-based substrate products, fabrics and roll goods and sheet materials that are used in a variety of applications. But we specialize in the fuel cell applications where we produce a gas diffusion layer, material that's it's applied on both sides of the membrane in a PEM type fuel cell. And the product produced in some volume at relatively low cost, and our challenge, of course, is to make a high-quality material that increases performance. So the distinction is Ballard Power Systems is a stack producer. We, Ballard Material Products, produce materials, engineered materials that have distinct characteristics as a component in a fuel cell stack.
So do you supply these components to Ballard Powered Systems only, or to the rest of the industry as well?
No, we supply the entire industry. We supply Ballard with gas diffusion layers for their stacks, for their applications. But our primary customers are the MEA producers. The MEA producers are the cell producers. They buy our GDL from us, and we're allowed to supply that product to anyone that's in the business, and we do. We deal with all the major MEA manufacturers.
The membrane electrode assembly manufacturers.
Yes.
So continuing, for those of us who aren't as technical, could you please explain what a gas diffusion layer does do within the fuel cell?
Certainly. The gas diffusion layer is a critical component of the membrane electrode assembly, which is in itself the powerhouse of the cell. The GDL has an important job. It has to conduct heat and electricity away from the cell so you can harness that electricity. It also has to convey gases and liquids into and out of the cell to make the fuel cell reaction occur. And it has to do all this while remaining highly stable in a hot, corrosive environment, and it needs to be stable for tens of thousands of hours. So a pretty important job. It's often overlooked because catalyst and membrane have captured the attention of the community, but the GDL itself is a critical performance driver and therefore a very important part of the fuel cell.
And why do you use carbon as a material choice for this layer?
Carbon is a pretty unique material. Carbon's a pretty unique material, of course. It's got characteristics that distinguish it as an element compared to many of the others. It has the properties of being electrically conductive. It's also a material that can be made very strong and stiff. It has unique chemical characteristics that in the case of the fuel cells, the material is inert and it doesn't really degrade over a period of time, so it's a very stable product, which is what you need for the function of a gas diffusion layer. So we work with carbon materials of all different types. We incorporate a number of different types of carbon in a gas diffusion layer. Not only carbon fibers, which hold most of it together and are used as a structural component, but also we use carbon powders and materials that are converted to carbon in the carbonization process and the heat treatment process that we use to manufacture the material.
So what applications do you use these for, aside from fuel cells then?
Well, the primary application is fuel cells, and most of our development focus has been around low temperature PEM type fuel cells, which is also the focus of our parent company. But there are other applications too. For the low temperature PEM, we've developed a portfolio of different GDLs. So for example, transportation or a bus or automotive or forklift GDL needs to be different from a stationary backup power telecommunications backup type GDL. So we have a portfolio of products there, but that's not all. We have products that are used in other applications as well, high temperature PEM, phosphoric acid type fuel cells, direct methanol fuel cells, and there are derivative technologies of fuel cells in which our products are also used. So we're talking about sensor applications, electrolyzers, there's quite a few. Chemical processing plants often use our products in their electrodes.
Okay, and what's quite interesting is I brought some of this product with you today. Can you talk a little bit more about them, giving us a bit of context of what they're like?
Sure. We make 3 different types of materials. 2 rollable products and 1 in sheet form. The rollable products, originally when we got into this business about 15 years ago, we manufactured a cloth or a fabric made by a textile process with yarns. And this is an example of the material. It's very much like any cloth that you'd see. It's very loose and pliable, and it has these kinds of characteristics. But as the market evolved, the demand for a lower cost type of a product became evident, and one that had some distinctive characteristics. So we went from the fabric, which is still used in a variety of applications, to a sheet type material like this is, which is quite stiff and has good compressive strength, high stiffness, and properties that are desirable for the modern type of a PEM fuel cell today. We not only make this in sheet form, but we also make it in roll form, and the rolls are used in continuous processing. Many companies, many MEA manufacturers these days are going to continuous roll-to-roll type manufacturing, which is probably the most efficient type of manufacturing for making an MEA. And so our products have been designed specifically for use on these high-speed, high-volume type roll-to-roll processing, where the labor content is extremely low, reducing the cost of manufacture. And in doing that, it does require that you have a very precise, consistent product, that every time a section of material goes into the automated machine, it has to have exactly the right properties, so that the stack producer can rely on the fact that all of the MEAs in there will function in a proper way. So that's a challenge for us, but many different types of carbon products.
So the title of your talk is Engineered Carbon Solutions. So where does the engineering come into your product?
Well, the main focus for us in the fuel cell market is clearly gas diffusion layer. We've developed standard products for gas diffusion layers, and we're selling those in volume. But that's not the only focus for us.
Okay. What kind of properties of the material can you affect? What can you engineer?
Well, any number of different types of properties. Lately, the more significant ones are surface characteristics, the relative smoothness of the material, compressive resistance of the product, stiffness of the product is important also. The ability to control the porosity and permeability and of the material, because gases and liquids both pass through the product. To do that very efficiently does require a design that is very specific to the application. Those kinds of properties are required. Other folks are looking for chemical purity. There are different levels of chemical purity that you can achieve based on the heat treatment methods that you use. So any number of variable properties can be affected by the way that we process the material. The challenge for us is to understand from our customers specifically what they're looking for, so that we can design with them a product that works best in the MEA.
And in the fuel cell industry, companies are learning that we have these capabilities to change our product, and it's led to us solving problems outside of the MEA, and even in some cases outside of the fuel cell stack, where material solutions are required. Our engineered carbon products with porosity, we can change them. What we do is we work closely with a customer who understands their application in detail. We understand the materials in detail, and through an open working relationship, time and time again, we can deliver a better solution than they had previously.
It's more complicated than it looks.
It certainly is.
But all this customization, it sounds expensive. How does this add value to your customers?
That's a good question. There's certainly a lot more upfront effort that's required, both on our part and on the part of our partner company. But I think we consistently show that by putting that effort in upfront, we deliver a better performance, a better cost-effective solution. And another thing, it's a rare thing where we have to go all the way back to the drawing board and redesign a material. We have all kinds of design levers that Bill mentioned, that by tweaking some of those, even to a minor degree, we're getting more performance out of the fuel cell than we've seen before.
Which obviously does affect cost, so it's a good solution approach.
Absolutely.
Well, cost by design is another issue that's important. Going in, the design elements that go into a gas diffusion layer, you have to deal with materials that are going to be inexpensive. You have to deal with processing methods that are going to be inexpensive also. Because in the automotive industry, for example, where they're expanding into many, many thousands of stacks, the production methods are going to have to be employed. You have to design up front for cost. And one interesting fact that kind of goes against perception is we use carbon fiber in our gas diffusion layers, and people have the perception that carbon fibers are expensive. Well, they're about $30 or $35 a kilogram for carbon fiber. But the interesting fact is, in our paper product like this, we only use about 18 grams per square meter of carbon fiber, and 18 grams of carbon fiber is about 0.4 euros cost. So it's 0.4. The carbon fiber material cost per square meter is 0.4 euros. And some of the targets for the cost of the material in high volume, we believe, are easily achievable through automated manufacturing and also through the design and low-cost materials that are going to be employed. So the labor element, the materials element is being reduced. So it's quite feasible for us to make a commercially viable product in volume.
Not only viable, and I think it's worth mentioning because it's unfortunately quite rare in this industry, you are a profitable business.
Yes, we are. One thing we haven't mentioned is that we use this technology in other applications, applications that go beyond fuel cells. Guy mentioned that there is a application for the chemical processing industry. In the chemical processing industry, the unique properties of carbon are useful in electrodes. But going beyond that, we also supply the automotive industry in fairly significant volume with friction materials that are used on clutches in automatic transmissions. On approximately 6 million vehicles a year, we're supplying this clutch material. It's made out of in this case, it's a fabric type of a product. Large volume manufacture to an automotive supplier, good profitable business. We've got a long-term supply contract. We also supply into the sporting goods industry, which is a high profit industry, with products that are used in the fishing, for fishing reels, for drag systems on fishing reels, and any number of different applications that go beyond what I've discussed. And so we're a diversified business, we're a profitable business, we're a cash positive business. Business is going to be around for a long time. Our focus has been on the fuel cell industry because we see the growth there, but there are a number of other areas where we continue to grow also.
Speaking to the future, do you continue to do R&D developments, and if so, what do you foresee?
Well, we never stop doing R&D really, but we've really crossed the boundary of R&D into commercial production. The various products we make as gas diffusion layers, they're being sold in volume today. And by that I mean many thousands of square meters annually to people who are making and delivering fuel cells of various descriptions. So while we're not in fundamental R&D all the time, we're continuing to look at new technologies. Most of our development resources now are spent working with customers in the fashion I described earlier, where we're just trying to get that much more performance out of the GDL that helps that fuel cell developer hit his long-term goals for performance and cost.
Great, thank you. Unfortunately, we're running a little short on time, but if you do have any questions, please come and see Bill and Guy at their booth. It's D62. It's just over in that direction. Thank you very much for coming.
Thank you.
Thank you.
Thank you, Christine.
Pleasure. Please do stick around. We have another interesting talk coming up right after this. Thank you.